The final brief thing I wanted to mention with regards to determining heat capacity experimentally is what do these instruments look like? And so, as was mentioned in the paper that we looked at, this quantum design company makes this thing called the Physical Property Measurement System, and this is their website. I just wanted to bring this up to show you what this looks like. So we have this whole thing here, and most of this is designed just to keep your temperatures at a very, very low value, right? So this is a cryostat up here, and a way to put in specific amounts of energy and be able to measure the heat capacity. So it requires an instrument that looks like this. I don't know how much this costs, but I imagine it costs a lot. And you can intentionally apply magnetic fields, but you can also not apply magnetic fields. You can get upgrades that have cryogen-free options. Though that would be pretty cool. And they have a bunch of different options here for electrical transport, thermometry, sub-Kelvin capabilities, microscopy, DC resistance, right? So you have all sorts of fun stuff that you can have inside of this. But the whole point of this is that you can keep your sample at a constant pressure, keep your sample at a fixed temperature, down from very low temperatures up to room temperature and higher, and measure those heat capacities. And then that lets you determine entropies, which from the entropies and other things you can find enthalpies and enthalpies of formation and all these other good and useful thermodynamic data. And once you've determined it once, that data is good for anybody to use, as long as you've done a good job measuring it. And so this is what the instrument looks like. If I zoom in a little bit more on here, you can get a little bit better view of it. But it looks something like this. You can see the computer on top here just to get a sense of the scale here.